Okay, we have some graphs here, displacement time, velocity time, acceleration time. Okay, and they're related to each other, and our job is to figure out how. Let's start with the first graph here. I'll circle letter A here in black. It looks like we have a beginning in a constant velocity here going in a negative direction here. We're initially maybe in a positive direction here, say east or north, and we're traveling back towards the origin. In order to do that, we must be going in a negative direction. So if I'm north, I must travel south to get back to the origin. If I'm east, I must travel west to get back to the origin. So to derive the velocity time graph, I must think slope of this line. So the slope of this line is a constant negative slope. So I'm looking for something that indicates that here. Okay, graph D shows a constant value for the velocity and then below the x-axis, meaning it's negative. Now since we're constant velocity, we do think of slope of this line here to get acceleration. The slope of that's going to be 0. So I go here, graph C, and the slope of that is 0 at all times. So the slope of this being 0 means acceleration is 0 the whole time. And let's change colors to red, circle graph B here. Here we've got a positive slope, but we're starting in a negative direction. Maybe we're west or south. Now we're moving either east or north back to the origin. Okay, so if we are west, we must travel east to get back to the origin, and likewise south, you must travel north to get back to the origin. The slope of this line is a constant positive. That will translate to graph letter B, or letter A here rather. So B for displacement translates to letter A. Why? Because the slope of this line is positive, and that is a constant value A in graph A here, a constant value for velocity above the x-axis. Now one more time, the slope of this line is 0, so we can circle graph C to represent graph A also, because both of those have an acceleration of 0. Okay, let's move to graph C. Graph C does start in the negative direction here, so again west or south, and we are gradually accelerating to a stop as we get to the x-axis here. So we start with a steep slope here, and then we are gradually getting less slope until we get a 0 slope here. So we're in the negative direction, west or south, accelerating to a stop towards the origin. Okay, so that means we must have positive velocity here, because that's a positive slope, going to a 0 slope. So that would correlate to graph C. So graph C here above correlates to graph C down here below. We have a positive slope going to a 0. So positive velocity going to 0. Now looking at this line, again, think of slope when you go from velocity time to acceleration time. I've got a constant value, okay, for a negative slope here, meaning the acceleration is constantly negative. Okay, down here, this is a constant negative here, below the x-axis for acceleration. So I will circle this. And lastly, group D. Circle that in blue. Looks like the opposite here. We're starting in the positive direction, but accelerating to a stop. Okay, we're starting with a steep negative slope here, going more and more and more shallower till we get a 0 slope here. Okay, that will correlate with our last graph B here. We have a larger negative velocity here and going at a constant rate until we get to 0 here. So again, a constant negative slope gradually becoming 0. Okay, one more time, look at the slope of this line to get to the acceleration graph. So B must correlate with A here. Positive slope constant. This is a positive slope constant. Okay, graph D, okay, does not correlate with any of them. This will be for a more complicated motion if acceleration is constantly changing. Let's analyze these two one more time. It looks like I have an upside down parabola. Okay, therefore, I get a line angled downwards and a negative acceleration. This parabola is upright. See the U shape here? That correlates with the line going upwards and a positive acceleration. So that's a neat pattern for us to look at as well.